Hi, M218. It's been a while. So today we're here to talk about simplifying radicals. Specifically, we're going to focus on square roots today. Okay, so in this very first example, I'm going to get right to it. Most people can tell me that the square root of 25 is 5. Okay, they can tell me that the square root of 16 is 4. But my question to you would be why? Why is the answer 5? Why is the answer 4? How do you know that? To find the answer to that question, we need to explore and break down 25. So when I break down 25, I'm usually a big factor tree person. I know that 25 is 5 times 5. Hey, wait a minute. 5's 5. I'm starting to see something here. Okay, so look at what I've done. I have rewritten the square root of 25 as the square root of 5 times 5. Now, when I have a radical that's a square root, okay, I always say a square root is like a 2-for-1 deal. Anytime you can group something inside and find two of those somethings, so 2 5s, 2 3s, 2 10s, 2 x's, anytime you can find a group of 2 inside, you get to pull one representative out in front. So the square root of 25 has 2 5's inside, and therefore 1 comes out, and that's why the answer is 5. Okay, I'm going to apply the same thing to 16. So let me break it down. Okay, so look what I've done. I've taken the 16 and I've broken it down to 4 times 4. So now I've rewritten it as the square root of 4 times 4. Okay, again, I can say, oh, there's 2 4's inside. So group them and pull one representative out in front. Okay, which is why I get an answer of 4. But you might look at this and say, well, 16, that can break down more. Those 4's, those guys can break down more. Breaking down the 4's into all the 2's, I would say, yeah, exactly. That 16 breaks down all the way to these 2's. But look at what I've got here. I've got a bunch of them. Let's group them by 2 at a time. So there's 2 2's. We'll pull out a representative. Okay, oh, here's another 2 2's. So we'll pull out another representative. If I have multiple terms out in front, okay, I multiply them together. So 2 times 2 right there, that's going to get me my answer of 4. Okay, your choice. Do you see that you don't need to go further than the 4's because you already have a grouping of 2, or do you need to break it fully down and do it as 2 groups of 2? Okay, new example. Can you break down the square root of 48? So you may want to take a minute, pause the video right here, and see if you can break down 48 and simplify the radical. So how'd you do? Okay, I chose to break down 48 as 4 times 12. And then the 12, I broke it down as 4 times 3. Right away, I saw a grouping of 4's. But let me rewrite it so you can see what I'm saying. 4 times 4 times 3. Okay, they multiply to 48. I didn't change that, but I now took that grouping of 4 out. So I get a final answer of 4 root 3. But what if you didn't do 4 times 12? What if you did 6 times 8? What if you did 2 times 24? Okay, the answer to that question is it doesn't matter. It doesn't matter if you start 4 times 12, 6 times 8, 2 times 24. As long as you break down the 48 completely and pull out as much as possible, okay? Every single time, pull out as much as possible, you are going to end with the same answer no matter what your first step breakdown is. Now, one piece of advice I will give you, if you're going to factor tree all the way down, it gets a little complicated. Okay, always take the last number, like at the end of one of your little trees. Like here, do not use the 4. Do not put the 4 in here because the 4 goes down further to the 2's. So I circled the end of every chain, if you want to call it a chain, the end of every tree branch or whatever you want to call it. I circle the end numbers so I know what to put inside. So it's just the ends. Now sometimes you'll see me, and in class I do this a lot. Once I break a number down, I cross it out. Break the 6 down, cross it out. Break the 8 down, cross it out. Break the 4 down, cross it out. And maybe that's a different way that helps you keep organized what to actually put inside. Okay? As long as you break 48 down into its prime factorization or into some shortcut version of it, you should end up with the same answer. Okay, another example, same idea, but this one already has a 3 out in front. So what do you do with that 3? You may want to pause the video here and see if you can break down 3 root 28. So how'd you do? I broke down 28 into 4 times 7. I broke the 4 down into 2 times 2. So therefore I'm saying 28 is 2 times 2 times 7. There's a grouping of 2 2's. So a 2 comes out. And what do? I multiply it by what's in front. So since it's a 3 in front, 2 times 3 gets me 6. And the square root of 7 is left inside. Final answer, 6 root 7. Okay, new example. So what do we do if there are two square roots being multiplied together? Okay, I believe that your fastest, most efficient way is to group them together inside the same square root. Okay, notice I am not saying simplify each side separately. Could you? Yes. The problem is after you simplify each side separately and multiply them together, then you're going to have to simplify again. 2 steps of simplifying is not fast and efficient. So fast and efficient is to put them together. Now notice, I did not say 12 times 15 is 180 or whatever it is. I don't care what it is. Okay, my next step is going to be to break them down. So why would I multiply them together just to break them down? That does not make sense. Okay, in case you weren't sure what I was saying, why would I multiply these together when I'm going to just break them all the way down into their prime factors anyways? Okay, so 12 times 15 breaks down into 2 times 2 times 3 times 3 times 5. Here's my breakdown of the product of these numbers. I don't care what their product was. All I care about is how I can see their product as a breakdown. So looking for groupings, I see a grouping of 2's. Pull out a representative. I see a grouping of 3's. Pull out a representative. And at the end of the day, what do I have? Out in front, I have a 2 times a 3, which gets me 6, but inside I still have a 5, so 6 root 5. Okay, another example. This is probably one of the most missed questions in this whole chapter. Okay, here's what everybody wants to do. They want to say, oh, a square and a square root, they cancel. A square and a square root, they cancel. So the answer is 2 plus 6, and they get 8. And they say, there's my answer is 8. And I say, no way. Okay, if we follow PEMDAS, let's do this problem right. PEMDAS says let's do the parentheses first. Sometimes people call this GEMDAS and they put a G here for the grouping symbols first. That means we're going to clean up what's underneath the square root first. You're not touching that square root yet, in other words. Okay, so we're going to go to the E. The E says evaluate the exponents. So now that gets me the square root of 4 plus 36. Okay, next step. Let's take a look. I don't have any multiplication and addition here, but I have some addition. That would come next. So the addition now gives me the square root of 40. Okay, now I'm ready to go ahead and tackle the square root. So you may want to pause here and see if you can finish the problem. Okay, I broke down the square root of 40. I've got 2 times 2 times 2 times 5. 2 2's, I see it. Group them, pull out a representative. These guys don't have enough to come out. So final answer, 2 root 10. Not quite the same thing as 8. Okay, last new main idea. So what does it mean when we say, well, let's rationalize the denominator? What does that mean? Remember, on the top of a fraction, that's the numerator, so the 3 is in the numerator. The square root of 7, that's my denominator. So when we say rationalize, okay, this is an irrational number right now. So we need to make this on the bottom a rational number. How do we make it a rational number? We get rid of the radical. So we need to get rid of the square root. Now, most people know what to do, but they don't know why they are doing it. So most geometry students can come in and say, I remember this. You just take whatever's on the bottom here and you multiply top and bottom by whatever that is. Okay, yeah, that's kind of true. That's kind of what you are doing, but that gives no rhyme or reason to why. Why are you multiplying top and bottom by this square root of 7? Why? Why is it this? How does that help? So let's go ahead and finish the what, and then we'll go back to the why. So I am multiplying by the square root of 7 over the square root of 7. When I multiply the top times the top, I get 3 root 7. When I multiply the bottom times the bottom, and maybe this will explain the why, I get the square root of 7 times 7. Okay, what did we learn earlier? We learned anytime there's two somethings in a set, okay, two sevens, it's in a square root, I cross it out and I pull out a representative. And if you look at what I've just done, now I have 3 root 7 over 7. Okay, what have I done? I have rationalized the denominator. Now all of a sudden, if I go back and put my big arrow there, there is no radical in that denominator anymore, no square root in the denominator. So what have I done? I've eliminated the radical from the denominator. How have I done it? So pay attention to my wording here. How have I rationalized the denominator? How did I eliminate the square root? I have looked here, okay, and I said I had 1 7 in a square root. I know that a square root needs two sevens to complete the set, two whatevers to complete the set. So I have figured out what was missing from the set, and I multiplied top and bottom by that missing piece. Okay. Anytime I talk about rationalizing the denominator, I always talk with my classes about completing the set. So when I looked here, I saw that I had 1 7, but I needed a second one. Okay, 2 of them in my set. There's 1, there's 2. That's huge. When you're doing cube roots and fourth roots and fifth roots, that's going to help you. Okay, if all you do is say multiply it by itself, that only works for square roots. And then when you get to algebra 2 and it's cube roots, third roots, cube roots, fourth roots, fifth roots, you're going to get those all wrong if you use that same mindset. So let's get the language now. Take a look at what's here, figure out what you need to complete the set. Okay, try really hard to keep this language with you. You want to complete the set. 1 7 needs a second 7. And that's why I chose to multiply it by root 7 over root 7, because this is what completes the set. So I listened to your feedback, and you had asked for extra examples. If you're feeling pretty confident in the material, okay, you can pause the video, stop the video, fast forward through this part of the video, your choice. But for everybody who wants extra practice, here you go. Take a few minutes, pause the video, and see if you can get through these two problems. So how did you do? Okay, square root of 28 times the square root of 21, you should have gotten 14 root 3. And for the square root of 5 6, you needed to rationalize it. So the top was okay, the bottom was a problem. So if you think about, here's 1 6, how do you get a full set with 2 6's? That leads you to thinking multiply top and bottom by root 6, and you get a final answer of root 30 over 6. Remember, root 30 does not break down.